Hello, geometry students. I hope that everybody is doing well. We are in the last section that we're going to be covering in Chapter 8, and it is Section 8-4, and it's about angles of elevation and depression. So what I'd like for you to be able to do by the end of this lesson is to identify and define what angles of elevation and depression are, as well as be able to use them to solve for missing values in real-world problems. So angles of elevation and depression are all over when it comes to, real life application, and they're just in the world all around us. But what are they? An angle of elevation is an angle formed above a horizontal line. Now, it's very important that you recognize it needs to be above a horizontal line. So notice here, I have a horizontal line going across, and then an angle is formed by a line crisscrossing that. This 38 degrees right here would be that angle of elevation, because here's the horizontal line and the angle formed is above it. So an angle of elevation, of depression is an angle formed below a horizontal line. Once again, I cannot stress horizontal enough. It has to be a flat line that it is being based off of. It is not vertical, it is not diagonal, it needs to be flat horizontal. So in this image, this same line being drawn across this horizontal line, this angle is now below the horizontal, so that's our angle of depression. Now, if I were to draw in a vertical line here real fast, like let's say that I had a perfectly vertical line, then these two guys would in fact form a right angle. So let's jump right in and do a couple word problems. In our first example, it says, from the top of a tower, the angle of depression to a stake on the ground is 72 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? Alrighty, we need to get an image and label what we know is going on. First thing we need to do is draw a picture. So it says from the top of a tower. So I'm just going to draw a little tower. And remember, I'm going to go ahead and put in a dotted horizontal line. This is my sky, but it is horizontal. I have to use the fact that I know that angles of elevation and depression go off of the horizontal. So it then says an angle of depression to a stake on the ground is 72 degrees. So let's just say that that stake is right here, and I'm going to draw in a line from the top of the tower, maybe, if I can get it at the right angle. There we go. The angle of depression is 72 degrees. So that is not this angle right here. It is actually this angle right here. This guy is 72 degrees because that guy is off of the horizontal. So this one right here is 72 degrees. And then it says the top of the tower is 80 feet above the ground. So I'm going to label that from here to there. This is the ground. I'll put in some grass for us. Okay. That is 80 feet. What we're trying to figure out is how far is the stake from the foot of the tower. So we're trying to figure out, I guess, how far is it from here to here. That's our x, our variable. Okay. What we now want to do is approach this just like we would, any other trig problem. So there's a couple things that I can think about. I can say, okay, these two guys are parallel to each other, the sky and the ground. So the ground is also horizontal. And I could say to myself, okay, well, that means that this guy and this guy are alternate interior angles, so that is 72 degrees. We can absolutely do that. We can say, okay, this guy is 72 degrees. You can also say, well, the vertical and the horizontal form a 90-degree angle, so 70 or 90 minus 72 is going to be 18, so this guy right here is 18 degrees. Doesn't matter which one you do, both of them are accurate. But what we want to focus in on is this triangle right here. That's what we're focusing in on. And we're trying to find this value. The only new piece of information or the new thing about this unit is we have a word problem, and that this was an angle of depression rather than just being told what was in the triangle. So we had to determine what the angles within the triangle were. So let's just pick one that we're going to use. I'm going to use this 18. And now we're going to go into trig. So we're going to say, okay, how does this x and how does that 80 relate to this angle 18? I'm no longer looking at this 72 because this 72 is outside of the triangle. I'm looking at what's inside. So this x is opposite while this 80 is adjacent. Now I'm going to write SOHCAHTOA up here. And we got to ask ourselves, what function, sine, cosine, or tangent, is going to use the opposite side and the adjacent side? Well, that's going to be tangent, so we need to set that up. I'm going to say the tangent of 18 degrees is opposite x over adjacent 80. Now I need to get this x all the way alone. The way I'm going to do that is by putting this guy over 1. I didn't change the value when I do that. And then I cross multiply. 80 times the tangent of 18 is just 80 times the tangent of 18 equals 1 times x, which is x. Now that x is entirely isolated, it's time for us to go to our calculator. So I'm going to turn it on, and then I'm going to type, let's see here, 80. So you guys can see the screen, sorry. Let me make sure it's visible, hopefully. So I'm going to type 80 tangent 18, and when I do that, I get 25.99, which is going to round up to 26. So x is approximately 26 feet. That's our answer. All right, let's look at example 2, or number 2. It says, lights for theater need to be angled correctly and focused. It requires precision and attention to detail. If a lighting designer has a light hung at 50 feet high, and the actor that the light needs to focus on will stand 20 feet to the side of the light, what angle of depression does the light need to hang? All righty, so let's just draw an image once again. So we have the ceiling, and that's going to be our horizontal again. And then we also have the floor, and we know that's horizontal as well. Now, hanging from the ceiling is a light, so I'm just going to draw kind of a image there. Here's our light, and we know that it is 50 feet up. We also know that an actor is going to stand 20 feet to the side. So it doesn't matter either side, but we're going to have an actor down here on the stage. And from the side of the light, it's going to be 20 feet. What we're going to try to figure out is what angle of depression does the light need to hang. So we're going to form an angle between the light and the person in order for the light to actually shine on that person. But what will this angle right here be? That's what I'm trying to figure out. Well, what I'm going to want to do first is to figure out what this angle is. What is that angle? So let's call that angle Y. And I'm going to use this to then figure out what x is equal to. So compared to the y, what sides do I know? What is 20 and what is 50? Well, 20 is the opposite side, and 50 is the adjacent side. So if I'm using SOHCAHTOA, I have to use tangent. I'm going to say the tangent of y, because I don't know that value, is equal to opposite 20 over adjacent 50. Now notice y is an angle. We were talking about this in class recently. When we solve for an angle, we need to take the inverse. So the inverse of the tangent of 20 over 50 is going to equal y. Whoops, when I put that into my calculator, I get 21.8. About. So this angle right here is what I just calculated because it's inside the triangle, and I'm getting 21.8. Now I need to ask myself, okay, if this guy's 21.8, what must the x be? And remember, a horizontal is going to be 90 degrees to the vertical. So I can just easily say, okay, 90 minus 21.8. And when I do that, I'm going to get that x value. So I'm going to say x is equal to 68.2 degrees for my final answer. In other words, this part right here, this x, and it's this guy, that angle is going to be 68.2 degrees. We have one more example on the back of our page. And it says, a ladder leaning against the house makes an angle of 60 degrees with the ground. The foot of the ladder is 7 feet from the foundation of the house. How long is the ladder? Don't even worry about angles and measurements yet. We need to get a picture going. So I'm going to draw kind of, you know, this is the roof of the house. And then the edge of the house. We got a door over here. So here's our house, and I'm trying to make it look, I'm trying to help you make sense of the image, hopefully. It's a brick house. Okay, so here's our house. And it says a ladder is leaning against it. So now we have this ladder, and I'll just kind of draw it like this. So here's our ladder. And it is 7 feet from the foundation. So in other words, the top is leaning, but the bottom from the foundation is 7 feet away from the base of that house. So from here to here is 7 feet. And it also says the lean that it has makes a 60-degree angle with the ground. So the ground is horizontal, and up to the ladder, it is 60 degrees right here. We're trying to figure out how long the ladder is. So I'm going to label that X. And then I'm going to highlight our triangle that we are focusing in on. Here is our right triangle. We're going to assume that this is a well-built house and that it is, in fact, perpendicular to the ground. Okay, so I'm trying to find a side length. So we're going to use regular trigonometry. And I have to ask myself, how does this 7 and how does this x relate to that 60 degrees? Well, the 7 is adjacent, and the x is the hypotenuse. If I write out SOHCAHTOA, I then ask myself, what function am I going to use? Am I going to use sine, cosine, or tangent? Well, which one uses the adjacent and the hypotenuse side? It's going to be cosine. So I'm going to say the cosine of 60 is equal to adjacent 7 over hypotenuse x. Now it's time for me to isolate the x. So I'm going to put that over 1 and then cross multiply. So x times the cosine of 60 is just x cosine 60. 1 times 7 is just 7. And now I have to get this x isolated. Remember, the cosine of 60 is 1 unit. You cannot separate. It is its own number. Cosine and 60 go together. So I am going to divide by the cosine of 60 on both sides. That cancels those out, and now I have x is equal to 7 divided by the cosine of 60. Now I can put that into my calculator, and when I do that, I have 7 divided by cosine 60. That gets me 14. So I now know that ladder. The ladder is 14 feet long. And there's my answer. All right, that's all for today's lesson of angles of elevation and depression. I hope you have a good night, and I'll see you soon.